Hello and welcome to another fun-filled day in math with Mr. Sims. Today we will be doing the Cycle 12 Test and Send a Video. I repeat, this is the Cycle 12 Test and Send a Video. It should be all kinds of fun and games. So what we're going to do today, like I said, I'm going to basically start off with 30 minutes and just see how many problems I can get through. Hopefully I can get through enough to make it worth your while and do well on the test. So without further ado, let me go ahead and set my timer after I get a drink, because I need a drink really bad. Now I'm good to go. Here I go. Yeah, drinking Coke. So, alright, Alexa, set a timer for 30 minutes.
30 minutes, starting now.
Alright, here we go. So write in an algebraic expression for the following phrase. This following phrase that they want us to write an algebraic expression for is the quotient of a number S and 25. So if I wanted the quotient of a number S and 25, then what that's telling me is basically the quotient tells me it's division. And the first number they tell me is the number that's going to go on top, and the second one is going to be the number that goes on bottom, or the number that it's divided by. So in this case, it's going to be S divided by 25. And that right there is my algebraic expression for the quotient of a number and 25. This is the other one from the study sheet as well. Write an algebraic expression for the following phrase: the quotient of a number R and 15. So this would be R over 15. All right. That's literally how simple it is. Once again, quotient means division. Aha! All right, let's go ahead and move on to number 3. Number 3 says the difference of two numbers is 7. Their sum is 11. Write the system of equations to find the two numbers x and y. So it says the difference of the two numbers. Let's see, difference. When you see difference, that means subtraction. And it says two numbers, right? And they tell us what they want these two numbers to be. They tell them they want us to be x and y. So I'm just going to say x and y is the same as equals to 7. So in other words, if I subtract x and y, it should equal 7. So my first equation is x minus y is equal to 7, because they say the difference of the two numbers, those are x and y, is equal to 7. Once again, I got x and y from here, right? Now it says their sum tells me it's plus, right? And their sum, they're talking about is my x and my y, right? So that's going to be equal to what? 11. So in other words, if I add x and y together, it should equal to 11. And that right there is my system of equations. They want us to write the system of equations, and we have done that. This right here is my system of equations. Once again, remember, system of equations is two or more equations that share the same unknowns. So the unknowns that they share are the x and the y, right? Those unknowns are shared. So it's two or more equations that share, right? They have to share, sorry about the chicken scratch, it's hard to write on this tablet, share the same unknowns, okay? But you get the idea. They share the same unknowns. All right, moving on without further ado, so we're not wasting time. Let's go ahead and move on to number 7 on the study sheet. Now, number 7 on the study sheet is actually kind of fun. Let me make sure I didn't miss any up there. I did not. Okay, perfect. So number 7 on the study sheet is about Bobby. And Bobby, he's going to school, so he's buying new clothes for school. Isn't that always fun? I love doing it. You know you do too. So Bobby is buying new clothes for school. Jeans are on sale for $12 each. And these are for the jeans. Now later on, they're going to tell, you know what, I'm just going to read it first. Let me just, without any underlining, let's just read it. Bobby is buying new clothes for school. Jeans are on sale for $12 each, and t-shirts are on sale for $5 each. Bobby spent $80 altogether and bought 9 items of clothing total. Write a system of equations that shows the number of jeans J and the shirts S that Bobby bought. So basically what I have here is I have a situation, Bobby, he's buying clothes for school. He bought jeans and he bought t-shirts. And basically they're wanting a system of equations so you can figure out how many jeans, how many t-shirts did he buy, how much money did he spend, all that stuff, right? So notice that there's money and there's objects. The objects are the jeans and the t-shirts, and the money is the actual money, right? So I know for sure I'm going to have two sets of equations. I'm going to have an objects equation, right? So this is my objects equation, and I'm going to have another equation. I'm going to have my money equation. And you don't necessarily have to label it like these. I'm doing this so that you have a good framework to work with, right? So I'm going to have a money equation here that's going to deal with the money, and I'm going to have an objects equation. So now that I've read it once and I know what's going on, I'm going to notice a couple things. The jeans are J and the shirts are S, right? The t-shirts are S. So Bobby is buying new clothes for school. That's just background, right? The jeans, we call those J, right? So the jeans are on sale for $12 each. So what that's telling me is that I'm going to multiply however many jeans he gets times 12. That's what the $12 each means. And the t-shirts, let's call those S, right? Because they want us to call them S. So S, the t-shirts, are on sale for $5 each. So $5 each tells me that it's going to be multiplied times 5. However many t-shirts I get times 5. And it said Bobby spent $80 altogether. So this to me looks like a total. And this looks like it's going to be the total probably for the money equation since it's $80. And he bought 9 items of clothing. In fact, this one even says total. So 9 items of clothing total. This is another total. And this total here is actually the total for my objects equation. So I'm just going to go ahead and start now. I'm going to, I like to put my totals first. So I got my objects equation. I know I'm going to have 9 total objects. And I know my money is going to be $80, right? So I like to put those first. Now, what comprises or what makes up that $9 of total clothing? Not $9, sorry. Those 9 items of total clothing. Well, it looks like they're going to be made up of my jeans and my t-shirts. So if I take my jeans and I take my t-shirts, right? What would I have to do if I take my jeans and I take my t-shirts? I would have to add those two, right? And I should get 9. In other words, the total number of t-shirts plus the total number of jeans should equal 9. And that makes sense. That's my objects. Now, my money equation, I have to look at these jeans and say, okay, well, jeans isn't really a unit of money, right? I have to basically convert that to how much he actually spent on the jeans. So the jeans are $12 each, so it's really going to be 12 times the jean. I see all that it was 12 times 12, right? So it's going to be $12 for every jean, so 12J. And then I'm going to add to that the amount that he spent on the t-shirts. So I'm going to have the S, right? Sorry, this is the S. All right, so the S times 5. So this is a 5 here. So 5S. So if I take 12J plus 5S, it should equal 80, right? Because it's $5 for every t-shirt and $12 for every pair of jeans. So this should be the total that equals the 80 here. And that right there is my systems of equations. If you were trying to fit that all on the test, you could just write J plus S, right? I find it always hard to differentiate an S from a 5. And then I would have 12J plus 5S, right, is equal to 80. Okay, so this would be what I would write on my test in that little box that we have. Okay, all right, so that's a system of equations for Bobby. Cool. All right, let's go ahead and do Lily with, a bouquet of lilies. So it says a bouquet of lilies and tulips has 18 flowers. Lilies cost $2 and tulips cost $3 each. The bouquet costs $44. Write a system of equations to determine how many lilies and tulips are in the bouquet. So basically what they need is they're telling us there's bouquets, right? There's a flowers, right? And each type of flower costs a certain amount. And they just want to write a system of equations to. It sounds like one's going to be for the actual flowers themselves and one's going to be for the cost of the flowers. So once again, we're going to have 2 different types of equations here. We're going to have an objects equation. I'm just going to write objects for this one, but okay. But I want you to know that means my objects equation. And then I'm going to have a money equation, right? The money equation. So my objects equation is going to be really well, you know what? Let's go through the problem systematically, and then we'll fill these out. But I can tell I'm going to have an objects and a money equation. So it says a bouquet of lilies and tulips has 18 flowers. Well, if it's 18 flowers, that sounds to me like it's a total of some sort, right? A total of 18 flowers. That's probably going to be the objects total. Lilies cost $2. Now, it said earlier that how many lilies, they want the lilies to be X. not L. They want us to be X, right? Cost how much? $2, and that's presumably $2 for each, right? So that's going to be X, whatever X times 2, right? So however many X I have times 2. And the tulips are going to cost $3 each, and they want the tulips to be Y. So I'm going to make my tulips Y, and they cost $3 each. So they're going to be times 3. And the bouquet together costs $44. So that sounds again to me like a total. That sounds like it's going to be the total of the money. So now they want me to write a system of equations to determine how many lilies X and tulips Y are in the bouquet. So I'm going to actually start with my objects equation here. My objects total sounded like it was 18, right? Right? And my two objects that make up those 18 flowers are my lilies and my tulips. My lilies are X and my tulips are Y. So if I take my lilies, X, and I add to that my number of tulips, Y, I should get 18. So in other words, X plus Y is 18. Now, the bouquet costs $44. So that sounds to me once again like the total of the money. And that bouquet, the $44, is comprised of two things: the cost of the lilies and the cost of the tulips. So to get the cost of the lilies, not just the lilies themselves, right? I have my X, but I have to take that X and multiply it by $2 per lily. So it's going to really be 2X. And I have to add to that the cost of the tulips. So the tulips are $3 each. So that's going to be plus 3 times the cost of the tulips, which is Y. So 2X plus 3Y is equal to 44. So I now have X plus Y equals 18, and I have 2X plus 3Y is equal to 44. So on the test, this is what I would write in that cute little answer box, okay? So hopefully that helped for that one. Let's go ahead and move on because we're just having so much fun. Yeah. All right, moving on. The sum of two numbers is 42. The difference of the two numbers is 14. All right, so let's look at this here. It says the sum of two numbers is 42. When it says sum, what that's telling me is there's going to be addition here. Two numbers. If I look at all my answer choices, it looks like those two numbers are going to be basically X and Y, right? So the sum of the two numbers is 42. So I can actually put my sum of those two numbers, X plus Y is equal to 42. And I can look for that right off the bat. So the only one that I see that has X plus Y equals 42, there's an X plus Y equals 42. This X plus Y is 56. This 2X is equal to 42. So really the only one I see that has X plus Y equals 42 is this one. This one here would be the difference of two numbers is 42, okay? So right there, I already know that that's the answer, but I like to just be thorough, so I'm going to go ahead and look at it a little more carefully. The difference of the two numbers, once again, difference telling me is subtraction of the two numbers. Once again, those numbers are X and Y, right? So if I subtract X and Y, I should get 14. So X minus Y equals 14. I see that once again here as well. So really, they were very nice to you on this question because on this question, both of these, the answer is only in one place. So you know that B is the answer. You feel very confident about that, right? So next problem. Woo! The graph of the function g. I like this problem. Okay, so the graph of the function g was obtained from the graph of the function f. Whenever you're doing these problems, you want to see which one comes from which one. And it sounds like the graph of the function g was obtained from the graph of the function f. So the graph of the function f started, and then we got to g. We moved to g using a transformation. So we did something to f to get G. And usually that's going to be the case where the previous letter in the alphabet, like A, B, C, D, E, F, G, G comes after it. So G normally is a result of the F, but you cannot, that's just not a guarantee. People like to be tricky, and so you need to make sure that you're reading carefully which one came from which one, right? So in this case, G came from F. We do something to F to get G. And if you look, F here, F right here is what we call the parent function. The parent function is y is equal to x here. So this is the parent linear function. It's just y is equal to x, right? Nothing fancy about that. You'll notice it has a slope of 1, right? The parent function always has a slope of 1. That's not pertinent to this problem in particular, but I wanted you to understand that that f that you see there is just the regular parent function y is equal to x. Now, what did they do to that to get g? Because g is the one on the bottom here. So it looks like to me, like they went down 1, 2, 3, 4. So it looks like they went down 4. So what they did was they actually changed the y-intercept and made it down 4. And the way you accomplish that is you take your f of x, right? And whatever your f of x is, remember, your f of x is going to be something like y is equal to mx plus b, right? If I wanted to make the y-intercept go down 4, I would just subtract 4 here and tack it on. So that's what we're basically doing here when we say f of x minus 4. We're basically taking that f of x value and we're subtracting 4. We're basically adding and subtracting 4 to our regular equation here, all right? If this confused you, don't worry about it. Basically what you have is f of x minus 4. What they did was they went down 4, and so we need to tack that minus 4 onto the end. So the one that fits that is this one here, j. This one here, if you ever see this plus 4 in with it, we're going to show you that later. If it's in with the x, that's actually going to make it go left or right depending on the circumstance. This one here would be changing the slope, and this one here would actually be making it go up 4, and we don't want that. So that one's out, that one's out, that one's out. The answer is J. All right, let's move on to the next one. I like those. Those are fun. They make me happy on the inside. Graph function g is the result of a transformation of the function f that is given below. Oh, before I forget, in your paper, right this very moment, at the top of the paper in the upper right-hand corner, you should have your name. You should also have your period number. You should also have your teacher's name. And underneath all that, I want you to draw a pig. Draw a pig. There should be a title on your paper too. That title can be Cycle 12 Test Incentive. Once again, Cycle 12 Test Incentive. All right, moving on without further ado. Graph function g is the result of a transformation of the function f that is given below. Okay, so this is the transformation right here. You have g of x is equal to f of x minus 3. Now, once again, because we have that minus 3 there, that tells me that what I'm doing is I'm actually doing a vertical transformation where I am going to change the slope, change the y-intercept by making it go down 3. So if I do that, I'm going to look for one where f, the parent function that we were used to, y is equal to x, that f thing, I want it to go down 3. This one looks like it actually goes up 3, so that one is out. That would actually be f of x plus 3, so that's not it, right? This one here looks like the slope is actually changing. Here you have your f value and it's changing slope completely. So this one is not it. That would be some type of stretch, right? Not what we're looking for here. We're looking here for a vertical transformation. This one here, once again, is a stretch, right? We're taking our line and we're actually twisting it, right? So that's actually also a stretch, not helping us here. This one here, however, yay, is the one I'm looking for because it looks like it went down 1, 2, and 3. It went down 3. So that's all right. So that's the g of x is equal to f of x minus 3. And you can actually see how it went down 1, 2, 3. It went down 3. In fact, every point on this went down. You can't just take one point and look at it because you have to look at the whole thing. The whole line went down by 3. That's why that minus 3 is that one there. So the answer is D. All right, let's go ahead and keep going. I'm loving it. So the graph of the function g is a result of a transformation of the function f. Now remember in the last one, the last couple that we've done, basically you've had the whole line shift. Well, if you look at this line, you might be tempted to say something crazy like, oh, well, this one went down 1, 2, 3, 4, 5, or maybe here, you might say it here. 1, 2, 3, 4, 5, 6. You might be tempted to say, oh, it went down 6, so minus 6 or something like that. But no, that doesn't make sense because even though it went down here, notice over here it went up. So whatever you choose has to make sense for the entire line. So in this case here, for this line here, I have this line and I have this slope changing. So what I've done here is this is called a stretch. I'm actually changing the slope of the line. So my line, I want you to recognize the slope of this line was up 1 over 1, which so it was a slope of 1. So the initial slope, or the slope of the f, right? The initial slope, sorry, my computer's freezing up on me a little bit. The initial slope is 1, or 1 over 1. Up 1, right? Up 1 and to the right 1. And I want to go from that 1 over 1 and see what did it become. Because whatever it became, I multiplied times that 1 to get it there, right? So I'm going to go ahead and look now and figure out what is my slope. So I need to find where this line here, it crosses here as a pretty point, but I need to see where else does it have a pretty point. And to me, it looks like, man, that's tough. To me, it looks like these are probably the pretty points right here. I think that's it. So it looks like to me it's going down 1 and to the right 2. So that's going to tell me if it's going down 1, that's going to be minus 1 and to the right 2. So in other words, it's down 1 and to the right 2. So I should see something with a negative 1/2 if I did that right. So in fact, I do have a negative 1/2. They were really nice to you because what they could have done was they could have put negative 1/2 here, and which would have been a vertical transformation. But remember, because we're actually changing the slope, it's not going to be tacked on at the end. We're actually going to have to multiply the whole f of x by it. So this negative 1/2, I'm going to multiply the whole f of x by it. And you have to be super careful here. Look at your slope. You'll recognize that's a negative slope. The most common mistake here is to forget to make it this negative here. And so a lot of people, there's going to be a ton of people who choose B because what they're going to do is they're going to say, hey, oh, it's 1/2 f of x, right? But look at that. That line there is not a slope of 1/2. 1/2 would be a positive slope, and that's clearly a negative slope, right? It's going down from left to right. So anyway, once again, the answer there is A, all right? Let's go ahead and move on. Write an equation of a line passing through the point 15,3 and parallel to the line y is equal to 3/5 x plus 6. Answer in slope-intercept form. Notice they were really nice to you. They bolded that, right? Write an equation of the line, once again, passing through the point. So they give us a point, and they tell us that it's parallel to this line. Well, why would they tell us it's parallel to that line? What's the whole point of that? Well, if you think about it to yourself, you think about if something's parallel to it, you know they never touch, yes, but that's not what we're interested in here. The reason they told us it's parallel is because parallel also tells us something about something very important. It tells us something about the slope. Now, hopefully, this is drawing some really cool bells in your head, and you're like, oh, yeah, I remember. If it's parallel, the slope is going to be the same as whatever it tells me. So it's parallel to this line here. So I just need to ask myself the question, what is the slope of this line? Now, they did a really good job. They made it easy for you by already solving it in y is equal to mx plus b. So I can see that that right there is my slope. Remember, my slope is 3/5, not 3/5 x. It's just 3/5. So my new line that I'm making, my equation of the line, is going to have the same slope because it's got to be parallel to it, right? So my slope, my 3/5 is equal to my m, and my point is 15,3. 15, comma 3. So 15, comma 3 is going to be my x1 and my y1. So now that I know that, I have a point and I have a slope, And there's a form of line I can write it in. Unfortunately, it's not slope-intercept form because I don't know the y-intercept, but I do have a point and a slope, so I can write it in point-slope form, which is y minus y1 is equal to m times x minus x1. And you do not have to remember this equation because it is on your star chart. It's a good thing to memorize, but if you don't remember it, you can find it on your star chart. It's probably not a bad idea to look at it. Just make sure you got the negatives in the right place and things like that. But now I just got to plug things in. Y minus my y1 is just going to be 3, right? I leave my y and my x here. I just have to fill in the y1, the x1, and the m. So y minus 3 is equal to my slope, which is 3/5 times x minus my x1, which is 15. And congratulations, that's the answer, right? Except it's not the answer. And if you did that, then unfortunately you got it wrong. You did all that work and you still got it wrong because you didn't read carefully. Before you put anything down on your answer key, you need to read and make sure you're answering the question. It says answer in slope-intercept form. That's so ugly. Answer in slope-intercept form. So what I need to do is I need to go ahead and I need to change this here. I'm sorry, this was x minus 15. I need to change that to slope-intercept form. So what that's going to be is I'm going to take that y minus 3. I'm going to start off by distributing that 3/5 in, right? I'm going to do that up here. I'm just going to move it up here, right? I got y minus 3 is equal to my 3/5 x minus, and now I need to do 3/5 times 15. So really that's 3/5 times 15. So my 3/5 times my 15. So 3 times 15 is 45. And that's going to be 45 over 5, right? 3 times 15 is 45. 45 divided by 5. 5 times 9 is 45. So that's going to be 9. So what I have here is 3/5 x minus 9, y minus 3. Now, I've seen a lot of people, they forget to this minus 3 over here, but you have to deal with that minus 3 by adding 3 to both sides. And you get y is equal to 3/5 x minus 6. And that right there is my final answer, and it is in slope-intercept form. If you're confused about what slope-intercept form is, guys, look at your star chart. It has all the forms on there, so you don't have to guess. You can remember and look at it, and you'll see that slope-intercept form is this. And you can see that I got it in slope-intercept form. I got my slope, I got my y-intercept, and so on and so forth, right? So that's my answer. So once again, look at your star chart. Your star chart is your friend. All right, I'm going to go ahead and do this one here. This is a geometric sequence. A geometric sequence is defined by the function f of n is equal to 3 times f of n minus 1, where n represents the position of a term in a sequence. That's very wordy, but it's fine. If f of 1 is equal to 11, what's the value of f of 4? So a couple things. First of all, you'll notice it's a geometric sequence. And when we learn geometric sequences, we learn that geometric sequences are multiplying or dividing by something. So there's where I can find my rule. I can find my rule right here, and that rule is right here times 3. So I'm going to multiply each jump times 3. It tells me my f of 1 here is 11. I'm not making a fraction here, guys. Don't think this is a fraction. I'm just labeling some spaces here, right? So this is f of 4, right? So 11 times 3 is going to be 33. If I times 3 again, I'm going to get 99. If I times 3 yet again, 99 times 3 is 297. You're not going to hear me say use your calculator a lot, but these are, when you do a problem like this, do use your calculator to make sure you get the jumps right? Because you'd hate to know the rule, know everything, and then mess up the jumps, right? So you can use a calculator to help you with the just the simple math there. Make sure you get it right, all right? Let me go ahead and continue, because well, why not? Yeah. All right, here we go. So which where was I at? Yeah. All right. Which represents a line that's parallel to the x-axis that passes through the point 3, 4. I've seen a lot of people struggling with these, and a lot of people are like, I'm so confused. Well, let's just take it step by step. For these, you need to draw it out. I'm going to just tell you, you need to draw it out. If you're not drawing it out, you're just being lazy. Don't be lazy. Draw it out. So I'm going to draw my, oh, that is a horrible point. I'm going to just go ahead and draw one axis, and then I'm going to draw the other axis, okay? So this is my x-axis. This is my y-axis, all right? We good? Now that I have my x and y axes, I'm going to ask myself the question, or read the question again. Which represents a line parallel to the x-axis? That means it's never going to touch the x-axis. That's telling me that it's going horizontally. I don't know exactly where, but that's basically what it's going to look like. Something like that, right? So it's going to be a parallel to the x-axis. And it passes through the point 3, 4. So I like to draw my point. My point is 3, 4. 1, 2, 3. This hasn't taken almost any time at this point. If you're thinking that it's taken a lot of time, then you need to change your work ethic, man, because let's face it, that is not difficult, right? So Alexa, stop the timer. All right, so this looks like it might be my last problem. There's one more after this, actually. I might try and fit in here if I can, okay? But anyway, here's the 3, 4. And this line, I want a line parallel to the x-axis. So my line, if it's going through that point, is basically going to look just like that. It's going to go through that point, the 3, 4. So since we know it's going to go through that point 3, 4, right? Then I need to ask two questions. Anytime you have a horizontal or vertical line, you're going to ask two questions. The first question is, what axis does it cross? So what axis does it cross? All right? Whatever your answer is, right, to this question, that's going to be your something equals. So what I mean by that is this. What axis does it cross? Well, this line crosses the y-axis. So that tells me it's going to be y equals. If it had crossed the x-axis, it would have been x equals, right? But it crossed the y-axis, so it's y equals. And this only works for horizontal and vertical lines. So once again, because it's a horizontal line, it crosses the y-axis, so it's going to be y equals. And the question I need to ask is, the second question I need to ask is, where does it cross the y-axis at? The place it crosses the y-axis at is right here at 1, 2, 3, 4. So it crosses the y-axis at 4, so my answer is y equals 4. Okay. All right, I'm going to do one last one. I know we're going over time just a little bit, but this question here is a big Mamajama, and I want to make sure that you are ready for the big Mamajama when it comes to get you. So, are you ready? All right, let's buckle up. So, last one for the night. The table shows selected values of the function y is equal to f of x. Find f of 4.5. Now, you'll notice on this table, there is no 4.5 here. Cry, cry, cry on the inside, right? I know. So, what you're going to do, we have to get f of 4.5. But there's really no easy way to do this. But there's ways that work. So let's go ahead and do the way that works. So first of all, what I have is I have a whole bunch of points, right? I'm going to call this my x1 and my y1, my x2 and my y2. And first thing I'm going to do is actually find the slopey, or the slope, sorry. My slope is equal to, once again, y2 minus y1 over x2 minus x1. And if I just start substituting that in, that's going to be 9 minus 7 over 16 minus 8. Now that right there is equal to 2 over 8, which is really 1/4. I did all that simplifying basically. I got the slope. But they don't want the slope. What they want, once again, is f of 4.5. They want me to put in x is 4.5. So what I need to do now is I have a slope and I have a point. So I need to make an equation in point slope form. So I have my y minus my y1 is equal to m times x minus x1. And if you were wondering how did I know that, I noticed because I looked at what I had. I had a slope and I have a point. In fact, I have multiple points here, but I'm just going to use this first point here. So I have y minus my y1, which is 7, is equal to 1/4 times x minus my x1, which is, here, 8. And this is a valid equation line. At this point, I can actually plug in 4.5 4x. And I think I am going to do that. I could solve it for slope-intercept, but you know what? Why bother? Oh, actually, yeah, I'm going to solve it for slope-intercept. The reason why is if I solved it right now, if I did it right now, some people would be messing up that -7 there. All right? So what I'm going to do is I'm just going to go ahead and distribute, get it in slope-intercept form. So I get 1/4 x, 1/4 x minus 2, sorry. I get y minus 7, right? Last step I got to do is add 7 to both sides, right? Sorry about the chicken scratch. I'm trying to rush so that you don't have to spend any more time than you have to. So y is equal to 1/4 x plus 5. And now I can plug in that 4.5. So I get y is equal to 1/4 times 4.5 plus 5. And to be honest, I'm doing this in the calculator right now because I just don't want to get it wrong. And 1/4 is the same as 0.25 times 4.5 plus 5, right? If I do that, I get 6.125. That's just an ugly answer. But if I was bubbling my answer, that's what it would be. So the answer, y, is equal to 6.125. And that is the big answer to the big Mamajama. So if you wanted to do the 6.125, you bubble that in on your answer key like you're supposed to. Anyway, I wish you the very best of luck. Thank you for sticking with me for that extra problem. I know that helped. At this point, in the bottom left-hand corner of your thing, I want you to write... what are you hoping to get for Christmas? What is the thing that you want to get for Christmas, or what one thing you want to do during the holidays? Maybe you don't celebrate Christmas and you just doing stuff for the holidays. What's something you really hope for the holidays? Like, are you hoping to go to the beach? It's cold. But anyway, you know, basically something that you're either hoping for the holidays or something you're wishing to get for the holidays. Let me think. What else? So we got something in the upper right-hand corner. We got something in the bottom left-hand corner. And let's go in the upper left-hand corner. I want you to draw a shooting star. So in the upper left-hand corner, draw a shooting star. Anyway, I wish you guys the best. You guys are amazing. Once again, I commend your effort. Thank you for being here, watching these. Encourage your friends to watch them, especially if it's been helping you out. Let them know that it's been helping you out, because sometimes kids don't think it will actually help them out. So let them know it is helping you out, right? Thank you for getting the 10 bonus points as well. That helps you out. It makes me happy when I see you guys just getting stuff right. So anyway, I wish you the very best. Thank you for all your hard work, and I'll see you next time.